Good evening all. Am I audible? Yeah, good evening all. Good evening all. Am I audible? Yeah, good evening. Immortal Warrior, thank you for your response. Rohit, good evening. Ajay, good evening. Yeah, good evening. Okay. Okay, so good evening all. This is Indra from Pantech E Learning. So today we are in our last day of this 21 days masterclass, right? So here we are going to talk about the final project, which is human following robot project. So this project uses a deep learning based object detection model, not object, it is a human detected model to detect objects, particularly human, right? So in real time using a camera. So it integrate motor control to move a robot towards the detected person adjusted based on their position. Okay. So without a delay we can directly go for our programming part and then we move to our final output, right? So for that let me get into my Visual Studio Code over here. Okay. Good evening all. So let me cancel this and let us go for a new one. Test.py. Okay. Okay. Let me cancel all of this. Okay, so here let me start, right? Okay. First, let's go with Python, or we don't need it anymore, right? Python test.py, and then we need to pass this proto text mobilenet SSD and the name deploy dot prototext dot txt and then model mobilenet SSD deploy dot cafe model. Okay. So now we need to import all the necessary packages that we need. Okay. So for that, first from imutils.video I am going to import video stream. Okay. So this particular line simplifies video stream handling and supports webcams and Raspberry Pi or Jetson camera. So before we have used something like cv2.video capture, something like that, right? So here I have already installed imutils. So from that imutils I have import the video stream. Okay. So now again, not this line. So from imutils.video I'm gonna import FPS. Okay, so here we don't need this much space over here. FPS. Okay, so it tracks the frames per second for performance measurement. Okay, so those who have asked for 19th and 20th day attendance, it have provided in the chat box. So those who doesn't fill the 19th and 20th day attendance, please mark your attendance without fail, right? we have already shared 19th day attendance. Yesterday some of you again and again asking for the attendance. So those who have didn't fill it, you can fill it. Okay. So those who have already filled your attendance, you can omit it. Now I am going to import numpy as np, and then I am going to import argparse. So it handles all the command line arguments. Okay. So now I am going to import imutils. So this should be in a new line, and then I am going to import time. It will delay with all the time delays and time management, and then at last the main thing, which is cv2, import cv2. So these are all the necessary packages that we need. Okay. So now let's initialize GPIO pins. So GPIO dot set mode. So m should be small only. Set mode. Instead I'm gonna pass GPIO dot. I'm going to take the board pin number only, and then GPIO dot set warnings. Here I'm gonna pass false. Okay. So see here, it suppresses the warning when GPIO pins are reused. Okay. So now I'm going to just print something like wait until device gets connected, just for a warning message. Okay. And then I'm going to pass something like, let it be, I just want to take the name as LEDs. Okay. So here we are not using any type of LED over here, but I am just taking the number 11, 16 and then 15, which are already connected motor pins. Okay. So now a list of GPIO pins are connected to other devices. Okay. So now let's get into the loop. So for I in LEDs, here it should be for, not for. Okay. So here GPIO dot setup. So here I'm gonna pass I comma GPIO dot out. I'm going to mention all the pin as output pin. Okay. So it configures each pin as an output pin for controlling external devices, right? Okay. So now let's construct the argument parse and parse the arguments. For that I'm gonna take something like argument parse AP, which is equal to arg parse dot argument parser. Okay. And here this particular line creates an argument parser object. Okay. Okay. So now let's create an argument parser object. So for that AP dot add argument. Here I'm going to pass few things, which is hyphen P hyphen proto text, and then required I'm gonna pass this as true, and then help here path to cafe deploy proto-text file. Okay. So this particular thing hyphen proto-text, that is actually the path to the cafe deploy file. That is a network structure. So that's why I mentioned all those steps over here also. This is the mandatory thing. Using this only we can run our program. Okay. Okay. So now again we need to do the things for cafe pre-trained model and confidence also. So for that let me copy the same thing. And again I am going to paste it. So here also instead of P, let's go for M for model, and then instead of prototypes we need to change this to model, and then required, which is equal to true, help path to the cafe pre-trained model. Okay, so we need to change this, cafe pre-trained model. This is what we need. And then now for confidence, so let me paste the same thing, and here instead of P we need to change this to C, and instead of this prototypes we need to go for confidence. Okay, and then here we don't need it anymore, so let me change this required. Here we need to pass the type. Actually type I'm gonna take like float, and then default, which is equal to 0.5, and then help, which is equal to, I'm going to change this, minimum probability to filter weak detections. Okay, at last arguments, which is equal to vars of ap dot parse arguments. Okay, so this particular line, it store the parsed argument as a dictionary. Okay, so now we are going to initialize the list of class labels, the MobileNet SSD that was trained to detect. Then we are going to generate a set of bounding boxes, colors for each class. Okay, so I already know this, classes, which is equal to, here I am going to pass all those steps, right? So first background, and then aeroplane, and then bicycle, and then bird, and then boat, and then let it be something like bottle, bottle, and we can give something like bus, car, chair, and let's give cow, and let's give dining table, and you can give dog, horse, motorbike, person, potted plant, sheep, and you can give like sofa. Sorry, I came out of this. Sheep, sofa, and then train, and at last I'm gonna give something like TV, monitor. Okay, so these are the classes that I want to give. So it generate random RGB colors before that, right? So here is a list of actually 21 object categories. So now I'm going to generate some random RGB color for each class to draw a bounding boxes. Okay, so for those we can go for colors, np dot random uniform. So instead I'm gonna pass like 0, 255, size, which is equal to, here I'm gonna pass like length of classes, and then 3. Okay, So this particular line, it generates the random RGB color for each class to draw a bounding boxes. Okay. Okay, so now let's load our serialized model from the disk. Okay, so for that, let me go with like, I'm gonna print here like info. This is, let it be caps for a reason. Okay, info. I mistakenly give, no, it should not be in the colon actually. Okay, so info, and after this loading model. This should be in, okay, now it's fine. Now net, which is equal to cv2.dnn.read net from cafe. So here I'm gonna pass args, and then here proto text. Okay, and after this again args of model. So model, args of proto text and args of model, right? Okay, so here cv2.dnn read net from cafe. This particular line actually loads the cafe model using args of proto text, that is network structure file, and then args of model, that is pre-trained weight files. Okay. Okay, so now let's initialize the video stream. We are going to allow the camera to warm up and initialize the FPS counter, I mean frames per second counter. For that, let's print, okay, info, and after this I'm going to give like starting video stream. Okay, and after this vs, which is equal to video stream. Here I'm going to pass the source, which is equal to 0 because I'm using USB camera, you all know that. I'm going to just start this particular thing. Okay, so this particular line starts the video stream from the default webcam. So if you are using Pi camera in the sense, I mean Raspberry Pi camera in the sense, you can change this line. So instead of giving source which is equal to 0, you can go for use Pi camera which is equal to true. So let me make a command over here so you can use that thing also. If you are using Pi camera in the sense, okay, here I am having USB camera. So if you are using Pi camera means you can go like use Pi camera which is equal to, you need to pass true. Okay, so those who are having Raspberry Pi camera, you can go with this line instead of that. And then time dot sleep. So here I am going with 2.0. It actually wait for the camera sensor to warm up. Okay, now FPS, which is equal to FPS of dot start. Okay, it start the tracking the frames per second, I mean performance monitoring. Okay, so now let's define the movement functions. We are getting into the motor things. So I'm going to def stop. Okay, and here inside this I'm going to give something like for I in LEDs. Okay, for I in LEDs, here I'm going with GPIO dot output of I comma GPIO dot low. Okay, so it turns all the LEDs off at first. Okay, so now okay, so now again, just a minute, let us give a space, it will be more clear to you. Now this is for left turn. Okay, so def left. So inside this I'm going to first print something like turning left. Turning left. Okay, and after this GPIO dot, we have mentioned this mode as output, right? So instead I'm gonna pass the LEDs of 0 and then GPIO dot, I want to make it high, so it will rotate the wheel accordingly. Okay, so similarly for 0 1 2 1 3, so let me copy this and let me paste. So instead of the 0 we can go for 1 and 2 and 3. Okay, so this 0 and 3 should be high and this should be low, then only it will turn the left. You can't make all the pin like high, all the pin like low, it won't work. So if you are setting 0th and 3rd one as high, 1st and 2nd as low, in the sense it will turn left. Okay, so similarly we need to do this for right, up and down. Up means moving forward, down means moving backward. Okay, so we have done with left, now we can go with right turn. Okay, so let me paste the same thing. Instead of left we can go for right. Okay, so here also RIGHT, right? Okay, so here everything is same. Instead of this we need to make this one as low, oppositely this and this should be high and this and this should be low. This will turn to the right. So now let's move to the forward movement. Okay, so for forward movement, let me paste the same thing. Instead of left we can go for up. Okay, and here also moving forward. Okay, and everything is same. Here this should be in low and this should be high and then low and then high. So this will move forward. So similarly for, let's go for backward also. So okay, so instead of up we can go for down, moving forward. This will moving backward. Okay, so here we need to change this simultaneously. So instead of low, high, instead of high, low, instead of low, high, and instead of high, low. Okay, yeah, we have done with the moving part. So now let's get into the loop over the frames from the video stream. So for that I am going to get into while loop. Okay, so now as usual we can go for like frame which is equal to vs dot read. Okay, so now frame which is equal to imutils dot resize. Here I'm gonna pass the frame and then the width which is equal to, I'm gonna set 400. Okay, so it actually grab the frame from the threaded video stream and resize it to have a maximum width of the 400 pixels. Okay, so now we are going to grab the frame dimensions and we are going to convert it to a blob. For that, here I'm gonna with height comma width. Okay, so here frame dot shape. So here I am going to colon 2. Okay, and then let's go for blob. So cv2 dot dnn dot blob from image. Okay, so here cv2 dot resize. Here I am going with frame comma here 300 comma 300, right, comma 0.0 007843 comma again 300 comma 300 and then 127.5. So what about this particular line? It actually create a blob pre-processed image. Okay, so with mean subtraction which is 127.5 and this is the scaling value. 0.007843 is nothing but a scaling value. So now let's pass the blob through the network and obtains the detections and predictions as well. So for that, net dot set input of blob, okay, and then detections which is equal to net dot forward and then detected which is equal to false. So this particular thing passes the blob through the network and gets detections. So now we are going to get into the loop over the detections. Here I am going to create a for loop. So for I in np dot arrange. So here I am going to pass 0 comma detections dot shape. So here I am going to pass 2. Okay. So now inside this for loop I am going with confidence which is equal to detections. Here 0 comma 0 comma I comma 2. Okay, so it loops through each detection and extracts its confidence score. Okay, so now let's filter out the weak detections by ensuring the confidence that is actually greater than the minimum confidence or not. For that I am going with if condition, right? So let it take a line over here. If confidence is greater than arcs of confidence, then inside this if condition I go with idx which is equal to integer type of detections 0 comma 0 comma I comma 1. Okay, and after this I'm gonna give like box detections 0 comma 0 comma I comma 3:7. Okay, so this should be multiplied with np dot array of width comma height comma again width comma height. Okay, and after this we can write it in the same line also. So here start x comma start y comma end x comma end y. Okay, so which is actually equal to box dot as type of inside I'm gonna pass integer type. So what does these particular lines means? Actually this particular line extracts the index of the class label from the detections, then compute the x and y coordinates of the bounding box for the particular object. Okay, so now we are going to draw the predictions on the frame. So for that I am going to take something like label. Let's just give me a minute. Detections. Okay. I mistakenly give it in the same line. Okay, now okay. So label which is equal to, here let's move with the set brackets. So colon and again set bracket, here format specifier. So colon 0.2f and after this percentage dot format. Inside I'm gonna passes the classes of idx comma confidence which has to be multiplied with 100, right? Oh, what did I do wrong? Here actually it should have that colon, right? Yeah, now it's okay. So now let's print it. So print classes of IDX. Okay, so now again see this, if string of classes of IDX, right, which is equal to, I am going to check whether it is a person. If it is a person in the sense, then I am going to give detector true. Okay, so after this we are going to calculate it. So center x, which is equal to start x plus end x, that has to be, sorry, modulus with 2. Okay, and then width, which is equal to end x minus start x, and then height, which is equal to end y minus start y. And then we need to calculate the area. How to calculate the area? Width, that has to be multiplied with height. So okay, at last we are going to print that. So like area comma area. Okay, and then we are going to print the center also. Center of x. Okay, so if the class is a person in the sense, then it calculate the center x, I mean the center of the bounding box and the box area. Okay, so now if that area is greater than 70025, so if this condition is true in the sense, then I am going to stop. Okay, so if it get closer in the sense, I am just going to stop. Elif, so center x is less than 170 in the sense, then we can go for left. Now we are writing code for how to turn that particular robot using our movement, right? So if I just close to the robotic car in the sense, it should stop. If I far away from that in the sense, it should move. If I go right in the sense, it should also move to my direction as well. Where I am moving, it should move. So for that we are writing. Okay, so now time dot sleep inside just 0.1 second is pretty much enough, and then it should stop. Okay, so now elif center of x is greater than 230 in the sense, then it should turn right. Okay, so time dot sleep of 0.1, and then it should stop. Okay, and then elif of center of x is greater than 170 and center of x is lesser than or equal to 230, then what it should do? It should go forward. Okay, so this is decision logic for movement. So stop if the person is too close, left or right, that is based on our position, and forward if the person is centered. Okay, so now let's draw the bounding box and label for detected objects. Okay, so cv2 dot rectangle. Instead I'm going to pass the frame, comma, here I'm going to pass start x, comma, start y, and then end x, comma, end y, and then colors of idx, and then comma 2. Okay, so it draw a rectangle, I mean the bounding box around the detected object. So here frame is nothing but the current video frame, and start x and start y is the top left corner of the bounding box, end x and end y is the bottom right corner of the bounding box. Color of idx, it that actually assigns a random color for the detected classes, and 2 is nothing but the thickness of the rectangle. So now let's display the object label near the bounding box. Okay, so for that y, which is equal to start of y minus 15 if start of y minus 15 is greater than 15, else we can give it in a single line. Okay, 15. Okay, so let us give a space over here. Okay, so let it be. So this particular line determines the y coordinate for placing the labeled text. If the top of the bounding box is high enough, I mean greater than 15 in the sense, position the text above the box, otherwise position it below the box. Okay, so now cv2 dot put text, here I'm going to pass the frame, comma, label, comma, start of x, comma, that y. Okay, comma, so now cv2 dot font Hershey simplex, comma, 0.5, comma, colors of idx, and after that the thickness of that particular text. Okay, so now okay, so now we can go for else stop, right? So if, okay, so now we can go for the next thing, which is if detected false. So it should be the false next condition. Let me scroll it down. Okay, over here. So now let's stop the movement if no object is detected in the frame. Okay, so if detected, which is equal to false in the sense, then I'm going to stop. Okay, so now let's print size, comma, frame dot shape. Okay, and then cv2 dot im show of frame and then frame. After that key, which is equal to cv2 dot weight key of 1 and 0 cross ff. Okay, and then if key, which is equal to odd of q, then break this. Okay, and now okay, over here fps dot update. Okay, and after that we can just stop all these things. Okay, it actually should be outside this thing, right? So after all these things, I'm gonna stop everything. So FPS dot stop. Okay. So now print info and then elapsed time. Okay. And after this, we can go for like 0.2f, that is format specifier, and after this format of fps dot elapsed. Okay, and after this line again, let me copy this and let me paste it over here. So instead of elapsed time, we can go for like approximate fpx. Okay, so approx dot fps, and then everything is same. So here instead of fps dot elapsed, we can go for fps dot fps, and then GPIO dot cleanup, and then cv2 dot destroy all window, and at last we can stop everything. So this is the program. I hope you understand all this program. So here actually I have recorded the video of how it actually moves, the car moves, right? So just before starting the live, I just record all these stuff because I can't able to show it in the live. I think I have a table, but I can't show it in the live. Let me show you the recorded video, and let me think I can able to show it in the live or not, right? So let me play this video. Please watch this carefully, right? See this, I'm recording it. If I come closer, it won't move. You can able to see the monitor here also. If we move, the robotic car will move to our side, right? Are you guys listening this? Are you able to see this? So according to our movement, it will also move. Let me try and show it in the live also, right? So just give me a minute. Let me give it a try.
Let me cancel this, and just a minute, let me go over here, and just a minute. Let me go for the terminal and let's try it, right, and we'll see what is going to happen. Just wait for a few seconds, let me arrange it and I will show you it in the live, right? Okay, so for that here we need to move to the directory first. Desktop, mobile net. Okay, so now I'm gonna paste it. I'm going to run it, okay? And let me show you, I'm having the camera with me. gonna run this. It's actually running, and it's actually moving. Let me open my camera and will show you. I hope you can able to see this, right? So it's actually moving. Okay. So you can able to see this, right? Here we are having some wires under the car. That's why it isn't moving properly. So see. So let me move. It should also move according to my direction, right? If I move this side, the car will also move. You can able to see this, right? If I get closer to this, it won't move. If I far away from that, it will move. Let me come this side. Okay. If we have power bank and we just place it in the floor, in the sense it will move fast. I'm just having the table, right? That's why. If you far away from that, in the sense it will, okay. It will run like this. I hope you like this, but I don't know. It will detect in the screen also, like person or something, and it will also print all these stuff. You can able to see this, right? The person, the area, the size, center, everything. Now it is detecting the person actually. What if I just show the bottle in front of it and let's see it is detecting it or not. Yeah, bottle, and here we are having chair. So this is a bottle and now it's me. It's detecting it actually, right? So this is how it will work, right? So if I move, it will move according to me. Okay. Okay, this is how it actually works. So now let me end it actually. I hope you like this.
Yeah. Do you like this session? Yeah, thank you for all your response. I hope you enjoy this. Again, this is the last call for this thing, which is actually today is our last day of this 21 days of masterclass. We came to an end, right? So today is the last call. If you want to convert this masterclass as an internship, in the sense, you can register today also. So this is a final call for final batch, and if you are registered for this particular internship, in the sense, you will be provided by 30 days of recorded sessions, 21 days of live session plus the 9 days all the exclusive part. You will get more content with some projects, and then all the presentations that we have used in this entire sessions and project codes as well. You can join to our community group and you will get LMS access for like 90 days, and after registration you will get your internship confirmation letter, and there will be a hackathon session. If you have any doubts, you can talk with me. I'm your mentor, so you can talk with me, you can clear your doubts with me. So you will getting mock tests, assignments and tasks as well, and at end of the day, today is the end, right? So hereafter, whoever paid for internship, whoever paid for the certificate, you will get all your corresponding certificates, participation certificate, internship certificate within 2-3 days. Okay, so please wait until then. And then this is only for 999 plus GST, and this is the registration link. This is the final call for batch 4. Okay, and now while how to do the payment, while making a payment, don't forget to add all these stuffs, because this is mandatory actually. And then you will be doing 4+ project with me in this particular internship. So this offer is going to end today. Okay, hope you guys are like all these sessions. I hope you all understand the topic very well. So please give it a try by yourself. I'm not forcing you to buy all these stuffs. If you are having with you in the sense, it will be helpful, but it's quite costly. I know that, but some of you may maybe want to buy it and give it a try, right? So many of you maybe in the final year or college students, if you are doing some projects in your college in the sense, you can just go with this Jetson Nano. It will be helpful and it will boost your resume, everything. Okay, so give it a try, and yeah, thank you for all your valuable comments, right? Yeah. So in future we will be floating more master classes in embedded domain only. So if you guys are interested in the sense, you can also register for that also. For embedded domain, I will be the mentor for you. So yeah, you will be get all the downloadables for the remaining 9 days. You will be get all the downloadable in your thing. So don't worry about that. Yeah, my LinkedIn ID. I will share my LinkedIn ID in the WhatsApp group, right? So I will ask your coordinator to send my LinkedIn mail ID, and you can mention it. Okay. So if you want to do any further projects in the future, in the sense, you can talk with our coordinator. So she will provide her the link in the chat box. You can go and grab it, right? Okay. So I noted some of you. Actually, I noted some of the name from the first day itself. So thank you for coming to the all classes without fail and asking doubts and clearing my mistakes, everything. So thank you all for this, and thank you all. Have a very great day. Let's catch up at some other classes in the future thing, right? So thank you all. Have a very great day.